All right, guys, this is lesson 1.2, and this is task 1, radicals and rational exponents. All right, it says convert between a radical form and a rational exponent form. Okay, a radical expression is an expression that contains the radical symbol, and this is known as a square root. In the radical expression, nth root of a is called the radicand. So the number under the square root, that's called the radicand, and n is called the index. So the little n, wherever the root is, that's called your index. Those are vocabulary terms that you need to be familiar with, which must be an integer value greater than 1. All right, for example, the radical expression, fifth root of 8, has an index of 5 and a radicand of 8, and is read the fifth root of 8. When n equals 2, the radicand is called a square root, and the index 2 is usually not shown. All right, so if it's got an index, then it's whatever that index is, that's the root. If you just see this symbol, that's known as just a square root. All right, recall that a power is a quantity that can be expressed as a base with an exponent. All right, so 3 to the 4th power is the same thing as 3 times 3 times 3 times 3, 4 times, okay? The large number is called your base, and the exponent is the small number above the base, okay? Together, this is called a power. The properties of exponents are shown below. All right, these are very important. Make sure you have all of these and examples provided in your notes, because you will use these for several lessons. And you will even use these again when you get to Algebra 2. All right, so properties of exponents. All right, so it says in previous courses you saw that the properties below apply to integers. In this lesson you will see that they also apply to rational numbers. So before you just seen integers, which are positive and negative whole numbers, but now you're going to see rational numbers, which means now they apply to fractions as well. All right, so the first property is a product of powers. All right, a product of powers. All right, so for any real number a to the m times a to the n equals a to the m plus n. All right, so basically when you're multiplying with the same base, you can add the exponents. And here's an example with numbers. Make sure you write these down. All right, quotient of powers. Product means multiply. Quotient means divide. So a quotient of powers for all real numbers, a not equal to 0 because you can't divide by 0. But a to the m divided by a to the n equals a to the m minus n. Again, when you go from division to subtraction, as long as you have the same base. And here's an example with numbers. Power of a product for all real numbers a and b. A times b raised to the n power equals a to the n and b to the n. So everything inside the parentheses gets raised to that power. That's called a power of a product, okay? Product, again, is multiplying. Power is your exponent. Power of a quotient. So that means an exponent for division, same kind of thing. So for all real numbers, a and b, with b not equal to 0, again, you can't divide by 0. A divided by b raised to the n power equals a to the n divided by b to the n. And again, here's examples with numbers. All right, a power of a power. For all real numbers a to the m raised to the n power is a power to a power. So you've got two exponents there. M and n both are exponents. That equals a m times n. All right, 0 exponent. This is important and a lot of people forget this one. All right, all real numbers where a is not equal to 0, anything to the 0 power is 1. All right, anything to the 0 power is 1, not 0. All right, this is an easy one, but make sure you know that anything to the 0 power is 1. All right, and a negative exponent for all real numbers a not equal to 0. raised to the negative n power equals 1 over a to the n power. So it becomes positive when you move it to the denominator. All right. You can define exponential expressions with rational exponents in terms of radicals by making sure the properties of integer exponents still hold true. Determine what real number 3 to the 1/2 represents. Suppose you square 3 to the 1/2 power to get 3 to the 1/2 raised to the second power. All right, so this is a power to a power because you've got 3 to the 1/2 power raised to the second power. So this one is a power of a power. All right, it says use the property to simplify the results of squaring 3 to the 1/2. All right, so if you've got a power to a power, remember you multiply powers. So what's half of 2? Half of 2 is 1, and then 3 to the first power is just 3. All right, what does this tell you about 3 to the 1/2 power? Select the value to complete the sentence. Well, 3 to the 1/2 power is the same thing as the square root of 3, okay? If you go back up here above and you see the n of a, all right, well, that just talks about the radical expression. All right, I guess we're going to get to that here in a minute. But what I want you to see is that if you have anything to the 1/2 power, 1/2 power is just another way. 3 to the 1/2 power is the same thing as the square root of 3. This is just two different ways to write the same thing. This is in radical form, and this is in exponential form. So you know how like 1/2 is equal to 0.5? These two things look different, but we know that 1/2 is equal to 0.5. So this is another scenario where these two things are equal. They just look very different, okay? All right. All right, so it says generalize your result. If a is greater than or equal to 0, a to the 1/2 equals square root of a. All right, that's all for task 1. If you have any questions, please let me know. All right, lesson 1.2, task 2. Convert between radical form and rational exponent form. All right, so it says examine the methods below to see how the power of a power property can be used to define a raised to the m over n power for any positive real number a and any integers m and n, where n is greater than 1. Since n is on the denominator, this has to be greater than 1, or we wouldn't have a fraction here. All right, so determine the missing steps by selecting the missing part of the equation. So we've got a raised to the m over n power, and that equals a to the 1 over n times m. So what they did is just break this into two parts, because you can write m as m over 1, and you wrote this as 1 over n. So that's just changing this into a power of powers property. All right, so then they're going to convert that to nth root of a to the m, and it says select the missing step in between. Okay, so what is the missing step? All right, the missing step is they're going to isolate the 1 over n together and then raise that to the n power. So all they did basically was take this from multiplication and then put this in parentheses to show that that is a power to a power. All right, determine the missing step by selecting the missing part of the equation. Okay, same kind of thing. A raised to the m over n power equals a to the m times 1 over n. What is the missing step? That's going to be a to the m times 1 over n And again, all they did there was add the parentheses to show that that is a power to a power property. All right, it says methods 1 and 2 show that when you are simplifying a rational exponent, raising to the m power and taking the nth root can be considered in either order. Give your own example of evaluating a to the m over n by choosing values of m, n, and a, where n is greater than 1 and a is greater than 0, and a is an nth power. All right, so let's look at some examples here. Well, if I can get my pen to work. All right, now that I've got my pen working, so we're looking for examples of a raised to the m over n power. So let's just do a to the 2/3 power. And then if I have a to the 2/3 power, I can rewrite that as a to the 2/1 power to the 1/3 power. And then I can rewrite that as a squared to the 1/3 power. And the 1/3 power, since that's on the denominator, that becomes your root. So cube root of a squared. And you can also write that as cube root of a squared. Both of those will work. All right, if you want an example with a number, we can do 4 to the 2/3 power. And again, we can separate this in a similar way, or we could do it in reverse. We could say 4 to the 1/3 power. Oh, that's supposed to be a 3. So we're just doing the denominator first and then squared outside of that. So this would be cube root of 4 squared, or cube root of 4 squared. All right, if you have any questions on task 2, please let me know.